Okay, tonight we are doing 6-1 roots of real numbers, and we're also going to do 6-2, and so I'll be honest, it's going to be kind of long today, but if you don't understand these two sections, you can't do anything in the rest of the chapters. So you want to make sure that you are really listening and focusing to these two sections that I'm going to do, and I'll try to do it as best as I can. When you have a square root, you're finding two numbers that are the same that you multiply together to get 9. So 3 times 3 is 9. So since they are the same number, you know that you are just going to have 3. Here, the only difference between negative square root of 9 and 9 is that you're going to have the answer as 3 with the square root of 9, but then you have to bring down the negative. There is a difference, however, if it was a negative inside the radical. If it is inside the radical for right now, you would write no solution. We're going to learn how to solve problems when there's a negative inside the radical sign, but for right now, you would know that it's no solution. However, outside's okay, you just bring it down. Here, whenever you have a fraction, you will take the square root of the top and the square root of the bottom. Well, 1 times 1 is 1, so I'll just have 1, and 3 times 3 is 9. So your answer is 1/3. Here with the decimal, same thing. You have to find 0.09. Well, if you have 0.3 times 0.3, you know that 3 times 3 is 9. And if you remember, whenever you're multiplying decimals, if you have two placeholders, because this is a placeholder and this is a placeholder, you have to move your decimal over twice. So that's how we would get the 0.09. So the answer is 0.3, because 0.3 times 0.3 is 0.09. Example number 2. If I give you x squared equals 9, and you are trying to solve this for x, the only way you're able to get rid of your squared sign, and that's this 2, is to square root both sides. So whenever you have a square, which is the 2, you square root both sides. And you know that x times x is x, so this just becomes x. And you know that 3 times 3 is 9, so this answer is just 3. However, since you square rooted both sides, there's a rule that says that you have to write plus or minus 3. So whenever you square root both sides of an equation, you have to write plus or minus 3. Here's the reason why. Wouldn't negative 3 times negative 3 also be 9? Sure, because a negative times a negative is a positive. So you're not sure if it's a positive or a negative answer, so you have to write plus or minus whenever you square root both sides. When you have an equation like this one, you have to move the 4 over and solve this. Before, we would try to factor it, and if you would notice, you couldn't factor it because it's not a difference of squares. But when we move the 4 over, we get this, and we would square root both sides. But I told you that whenever you have a negative inside the square root, for now you have to write no solution. Which makes sense because when we were factoring these, we couldn't get a solution. We couldn't factor it. C. What if I gave you 5x squared equals 15? The first thing I would do is I would divide both sides by 5 because 5 will go into 15 evenly. So I'm going to have x squared equals 5 goes into 15 3 times. And then I square root both sides. And remember, whenever I square root both sides, I have to write plus or minus. And I can't break up radical 3. There's no two numbers multiplied together that give me 3, so I leave it alone inside the radical sign. Sample number 3. cube root of 8, okay, you want to ask yourself what three numbers, that's what this is called an index, but it's whatever this number is, you're finding three numbers that will multiply together that equal 8. So if you notice on all the other ones, we've been doing the square root. And if you notice, I didn't have a 2 on the outside of these because it's just assumed that if you just write the radical sign without an index number, that it's just 2, and you're finding two numbers that are multiplied to give you the inside number here. But here, there are you need to find three numbers. So 2 times 2 times 2 is 8. So that would be your answer, 2. Here, what if I gave you the cube root of negative 27? Now, before I told you if you ever had a square root of a negative number, the answer was no solution. Let's go back and look at that one because I think I need to explain why. With a negative 4, there is no two numbers that multiply together that will give me a negative, because unless I do a positive times a negative, but again, those would not be the same numbers. So I know that 2 times 2 is 4, but that's not negative 4. And I know that negative 2 times negative 2 is 4, but again, that's not negative 4. So none of those work. You can't get a negative answer inside. However, when it's cubed, that's different. Let's just look at it as 27. You know that 3 times 3 times 3 is 27. However, if I put negative signs in front of these, and I do negative 3 times negative 3 times negative 3, I'm still going to get negative 27. So when it's an odd number, you can, C-A-N, you can have a negative inside the radical sign. But if it's an even number, it is always no solution because you can't ever get a negative answer. C. What if I gave you the cube root of 10 to the 6th power? There's two ways you can do this. You can either write out what 10 to the 6th power is and then find three numbers that multiply to give you that number, but I think that's harder. What you want to use is this formula, and I'll write it up here. And you're going to see this again when, we'll do P over Q, when we get into another section. Whenever you have a cube root or whatever it is, a square root, and you have a number in here, an exponent, you can just write your base number and have it P over Q. So for this, how does that relate with the formula? Well, this would just be 10 to the 6 over 3. Well, we know that 3 goes into 6 twice, and 10 squared is 100, and your answer would be 100. So that's a little trick to help you so you don't have to find a huge number and cube root it. And again, you're going to use this over and over again coming up in another section. D. The cube root of a to the 9th. Again, let's use this formula at the top here. And I always tell my students that the inside one is always on the top and the outside one is always on the bottom of the fraction. So we're going to have 9 over 3. 3 goes into 9 3 times. So your answer is a to the 3rd. Example number 4. The 4th root of 81. I'm going to write them all out. B is going to be the 5th root of 32. C is the 5th root of negative 32. And D is the 6th root, of negative 1. Okay, same thing as we did in example 3A and B. you want to ask yourself, what four numbers multiplied out give me 81? Well, 3 times 3 times 3 times 3 is 81. So your answer is just 3 for A. B, you have to find what 5 numbers multiplied together give you 32, and that's 2 to the 5th power is 32. So your answer is just 2. Here, it's a negative, and it's an odd number. Well, we know that when it's just 32, our answer is 2. However, it's a negative inside, and it's odd, so we know we can have a negative 2. And if you multiply that out 5 times, you will get negative 32. Here, we have the square root of negative 1 to the 6th power, but this is even, and if you remember even numbers, you can't get a negative inside, so it's no solution. Because if you multiply negative 1 out 6 times, you're going to get a positive. Let's go on to the next section. That was 6.1. We're going to go to 6.2, properties of radicals. With these ones, they're not going to work out perfectly. Meaning, before, if we had like the square root of 81, you would know that 9 times 9 is 81, and it's a perfect square. These aren't going to be perfect squares, and they're not going to come out evenly. So, for example, if I have the square root of 98, there are no two numbers multiplying together that are the same that give me 98. So here's how you deal with these type of problems. You would look here and you would go, okay, what times what is 98? Well, let's do 2 times 49. And I'm going to do a factor tree like we did when we were doing the LCD and the GCF. So I'm going to do my factor tree. And here are my prime numbers. And I would go, okay, I'm going to circle all my partners. So I have a partner of 7, and 2 doesn't have a partner. It's all by itself. Whenever you circle a partner, it becomes one of those numbers. So since there's 2 7s, now it's just 1 7. And whatever is left over, which is this 2, that stays inside. That can't escape because it doesn't have a partner. Let's do another one so you can see more what I'm talking about. If you have the cube root of 25 times the cube root of 10, I would go ahead, and since they're both cube roots and it's not a square root and a cube root, you can go ahead and multiply the inside of these two numbers together. So I know that 25 times 10 is 250, and it's still a cube root. Don't forget to write that because we don't know. We got to make sure we keep our index there. So we have 250. Now I'm going to find, and in this case it's 3 buddies because it's a cube root of 250. So I know that 125 times 2 is 250, and I know that 3 times 25 is 125. Excuse me, I'm at 5 times 25 is 125. And then we know we can break up this, and it's 5 times 5. And so now we're going to find our partners of 3, or buddies of 3, however you want to think of it. And here's 3 5s. So I know that they can escape, and I have to look to see what's stuck inside that's a prime number. Well, the only thing that's stuck inside is the 2. So that's a 2. However, if you notice, I'm missing my index number. I have to write the 3 here because otherwise it looks like a square root, and it is a cube root. C. The cube root of 81, over 8. Looking here, I have to break this up because it's a fraction. So I'm going to find the cube root of 81 and the cube root of 8. So you have to ask yourself if there's 3 numbers multiplied together that give you 81, and if there's 3 numbers multiplied together that'll give you 8. Well, we know that 2 times 2 times 2 is 8. So this is just going to be a 2 on the bottom. However, we're going to have to find buddies for 81 because it's not a perfect cube. So I know that 9 times 9 is 81, 3 times 3, and 3 times 3, and now I have my prime numbers. I have to find partners of 3. So I have 3, and then I have a 3 left over, and then I have to write my 3 for my index. Lots of 3s. So when I look at this, if this could reduce the 3 and the 2, you would. But you can't, so this is your final answer. D. I have 60, and it's the square root of 60, and actually they write it with them separate, like 60 over, double check, 5. Goodness sakes, 5. Okay. So it already split the radicals for you. However, if you notice, if we were to write this as one radical, like one fraction underneath one radical, which you're allowed to do. It's just like we did here, we split it up because it originally was 1. Well, you can also have one that's split up and write it as 1. And the reason you'd want to do that is because 5 goes into 60, and that reduces. So if 5 goes into 60 12 times. So now I just have to find my buddies for 12. And I know that 4 times 3 is 12 and 2 times 2. And I know that this is my partner, and I would have a 3 left over that didn't have a partner. And so this would be my final answer. This makes it a lot easier to do. Sample number 2. I have the square root of 2a squared b. Alright, so looking at this, let's look at just the number first. Okay, so we have a square root of just 2. Forget the variables there. We know that we can't find any partners, or even if we broke like 2 times 1, we're never going to get that 2 out of the radicals. So we know we're still going to have that stuck in here. However, we have an a times an a, and those are partners, so we can put the a out here. B doesn't have a partner, so it stays inside. This would be your final answer. And this is example A. I'm sorry if that confused you. Example A. B, the square root of 36 w to the 3rd power. Well, let's look at the number first. 6 times 6 is 36. So we can break that out. And we have w times w times w. We're finding partners, so this is going to go out with the 6, but we have 1 still stuck inside. And this would be your answer. C. What if I had the cube root of x to the 5th, y to the 3rd? So on this one, we have to find buddies of 3 for our x. So we can split this cube root, and it's, I should say not buddies, because it's going to, well, buddies of 3. So it's going to be x to the 5th over the cube root of y to the 3rd. So let's look at the x. We know we have 1, 2, 3, 4, 5 x's. And we're going to circle partners of 3. So we know that we can pull out 1x, but 2 of them are stuck inside, correct? So I know that I have the cube root of x times x is x squared. You got to multiply your extra ones together. Here, you have 3 y's. So we know that that's just going to go away, and we're just going to have a y on the bottom. This is your answer for 3. And you could also use my formula. 3 divided by 3 is 1, so y to the 1. Either way of thinking of it should work. D. I have the square root of 4a squared plus 4b squared. When we look at this one's kind of tricky, but if you follow me here for a second, if you can take a GCF out of here, because you're kind of looking at this like kind of a factoring problem. Well, we could take out a 4, and we'd have a squared plus b squared left over. And when I look at just 4, we could take the square root of 4, and you know that that would just be 2. So I'll write that square root of 4, we know we would get 2. And if you look at just the square root of a squared plus b squared, you would try to see if you can get 2 factors that are the same to get a squared plus b squared. And there isn't anything, this isn't factorable, so that would be left alone because you wouldn't find 2 factors that would be able to make a square root. So this is your answer. Okay, I'm on the last one, believe it or not, I promise, and it's only 2 questions, an A and a B. Example, I don't even know what I'm on, 3. A. It says, simplify, and it gives you 5 divided by 3, and B is going to be the cube root of c, and it's actually a fraction, so 4 is on top. I kind of wrote that weird, but it's 4 divided by the cube root of c. Looking at this one first, I would go ahead and break up this square root, and I would have radical 5 over radical 3. You know you can reduce your fractions, so you want to break them up, and you'd be like, oh, okay, well, I can't find partners for anything. And you're never allowed to leave a square root in your denominator. That's a big important rule. So whenever you have something in your denominator that's a radical, in order to get rid of it, and if it's a square root, it's to multiply it by itself to the top and the bottom. So whatever your denominator is, you're going to multiply it to the top and the bottom. 5 times 3 is 15, and 3 times 3 is 9. The square root of 9 is 3, so we got rid of our square root. And then we would have to look at 15 and see if we could find buddies. We can't, so we're just going to have it as the square root of 15 on top. This one right here, I have the cube root of c on the bottom, and we want to make it just a c. So we got to multiply it by the cube root of something to the top and the bottom because it is a cube root, not a square root. So you want to get c times c times c so that we could just have the answer c on the bottom. So we can find buddies of 3. So you have to ask yourself, c times what is going to give me, in this case, c to the 3rd, right? Because that's what that would be. And so I know that c times c squared, 1 plus 2 is 3. So I would have a c on the bottom, and I'd have 4 cube root of c squared. And you can't break up c squared, so that is your answer.